Hi, I'm Jack. I'm a sound designer with a decade of experience as a vehicle technician. In this video, I'm going to be walking you through how I've implemented transmission and turbo audio using Unreal Engine 5 and Wwise. So, for the transmission, I wanted to design a system that allows for gearbox whine depending on vehicle speed and current gear rather than RPM, with louder transmission whines on load on. I also wanted to implement a gear shift audio system that represents the player's camera perspective in chase, hood and cockpit views. The transmission audio system is driven by a play transmission whine event, transmission speed RTPC, a transmission load RTPC, and upshift and downshift events. As this system is mainly collecting vehicle data on tick and also collapsed into a function, I've used a Boolean gate to post a transmission whine event on the first frame only. The transmission load RTPC is based upon a smooth throttle input, and the transmission speed is calculated from the vehicle's forward speed and current gear with a gear ratio multiplier to reset the transmission speed after every gear shift occurs to closely simulate how real gears work. Gear shift up and down events are posted by comparing the current gear against the previous gear. If the new gear is higher, it triggers an upshift event, and if it's lower, it triggers a downshift event. In Wwise, the transmission whine is created using a looping-based system in a blend container. The blend container holds multiple looping speeds of a gearbox recording, with pitch and volume rising slowly as the transmission speed increases. The upshifts and downshifts are separated by exterior and interior variations within random containers, with a single top-end sweetener for each shift type for the hood view. These are all mixed by volume and filtering depending on the camera state. In order for the gear shifts to cut through the low end of the engine audio in the mix, I have set up a multiband sidechain bus. Both the exterior transmission shift containers are sending a signal to an aux bus with an EQ that is only allowing a frequency range of around 300 Hz to pass through. In the meter plugin, I measure the level of this signal and convert it to an RTPC with a minimum of -48 and a maximum of 0 so it matches the meter. I then use a gain plugin on the end of this aux bus to meet the output of this send. And then for each of the engine perspective actor mixers, I set up another EQ to then receive this signal and attenuate a low shelf gain. Here's a quick example of the system working. So the goal for the turbo system was to recreate the behaviour of a real turbo and blow-off valve setup in a simplified but believable way. Real turbos are powered by exhaust gas flow that spins the turbine and compressor wheels. This then rapidly sucks in air and forces it into the combustion chamber. The time it takes for the turbo to spin up is what we call turbo lag. Once you let go of the throttle, the turbo will still be spinning and the trap boost will have nowhere to go but force its way back down the turbo, which is where we get this famous sound from. Although it does sound cool, in real life it creates early wear on the turbo, so blower valves were invented to counteract this by releasing the boosted air to atmosphere once the throttle is let off, with the amount of air being released depending on how much boost has already been built by the turbo. So for my design, I wanted to replicate this by allowing the car to build turbo spool based on load-on values and an RPM threshold, whilst driving a continuous turbo spool through a Wwise RTPC. I also wanted to control different intensity blower valve events based on if the turbo spool had started and how much turbo spool was present before throttle liftoff. Here's how the logic works in blueprints. On event begin play, we post the turbo spool event. If the throttle input is over 65% and the RPM is over 2.5k, the turbo will begin to build spool. The spool value is then smoothed and then used to set the turbo spool RTPC in Wwise. The throttle delta then detects a sharp throttle liftoff, and the previous spool value detects how much spool existed before the throttle liftoff. We then use those conditions to confirm a blower valve event should happen and reference the turbo previous spool value to set the blower valve intensity and the intensity RTPC for volume control in Wwise. We then compare the blower valve intensity variable against low, medium or high thresholds to set the Wwise blower valve intensity switches and post the event. In Reaper, I've used a looping air sound for the turbo spool. And for the blower valves, I split them into single front end diaphragm one-shots and 3 tail variations for low, medium and high. This means I can randomise the front and the back end of the one shot slightly and get more variations so the listener has less chance of hearing repetition. In Wwise, the turbo spool file is simply set to loop infinitely with the turbo spool RTPC mapped to high pass filter, pitch and volume. So as the spool value increases, the sound gets fuller, gets higher in pitch and gets louder in volume. For the blower valve one-shots, I've set up a switch container and assigned the assets to the corresponding switches, with the tail variations nested in random containers. Rather than using a sequence container, I've set these up so both the diaphragm and the tail play at the same time. The switch container also has a voice volume curve mapped to the intensity RTPC, meaning that the switches are louder when at higher intensities and quieter at lower intensities. As with the other audio systems, the turbo spool and blower valves are also state mixed via camera perspective on the actor mixer. Here's how the transmission and turbo sound with the engine. So that covers the concept, logic and blueprints, the asset design, and Wwise implementation and mixing. Please check out other videos where I'll go through further systems in more detail. Thanks for watching and feel free to reach out using the links in the description.